Optimize your learning in computer science, you want to follow the PRIM framework. Let's start with the first letter, P, for predict. So let's take a look at an example. So over here we have the example Slinky, where there's 10 lines of code in total. The first thing you do when you see an example program over here is you want to predict what do you think will happen. So you want to start looking at like the first line of code over here and be like, okay, line number 1, circle 35. What do I think that's going to do? Now you might be like, okay, circle, it'll probably make a circle. 35, I don't know what 35 is size-wise, but it's a circle at size 35, however big that is. And then, okay, next thing is it's going to move forward for some amount, whatever 20 means. And then, okay, we have another circle at the same size, and then forward again. So like you're trying to go through and predict what might happen. Once you have P predicted and trying to figure out what happened, I don't care if you're right or wrong, you want to spend the time to think, what is the thing that might happen? People who have that prediction have far superior memory than people who don't predict. Science shows just guessing helps you remember. So next up, you've taken a guess, you've thought, and this is what I think is going to happen. Next up is going to figure out what is going to happen. So you have R, which stands for run the code. So run your program over here by clicking run, and then your goal is to see, did what I predict actually happen? Yes, great. If not, even better, now I get to investigate why this thing did what it did. So R is run the program. So first you predict what's going to happen, and then actually put your feet down and be like, this is what I think, even if you're wrong. Then run it, see what happens, and now it's time I to investigate, where you're going to ask yourself, okay, this is what happened. Do I understand what is happening? So start by looking at line by line. So circle 35, forward 20 over here. So line 1, make sure you can say and think what is going to happen. It's going to start by drawing a size 35 circle. Line 2, Tracy's going to move forward 20 pixels, and then it's going to repeat a total of 5 times. All right, now I feel like I've investigated. I understand what's going to happen. And now to finish my investigation up, I'm going to now modify what it is. So for example, over here, to really get a feel for what it's going to happen and get a feel for how big 35 actually is, maybe I modify 35 to be over here instead of 50. So I now have 2 circles moving at 50 instead of 35. So if I Alt-Tab over to this right now and I go over to Slinky, if I ran this, you can see that that's what's going to happen. And if I change my circles to be 50, you want to actually modify the program over here and try and get a feel for what's going to change. So I changed that over there, and I noticed the circles are, well, definitely bigger because they're bigger than 35. But how much bigger? And you can kind of see then, okay, what's double 35? Double 35 is 70. Is that circle going to be double as big? So you're modifying it and trying to get a feel for how big stuff is. If you go into documents at any time, you'll also be able to see all of the possible commands that Tracy has available to her, which is all the stuff over here. So that's really what you do for an example program over here. It's the first 3 letters of prim. You want to predict, you want to run, you want to investigate over here. The last 2 letters, modify, are important, kind of really understanding it. And then to me, the most important stage of it is the last stage, which is make. And to make something, you need to now use what you explored, and you need to solve some sort of new problem. So that new problem that you're solving is going to be directly after that. So after you work with an example program over here, the next program you're going to do is Stretch Slinky, for example. And Stretch Slinky over here is a problem-solving activity. It's giving you over here just the basic commands. And under Show Exercise, it specifically wants you to solve a certain problem. The circle should have a radius of 35. And Tracy should move forward 40 pixels after every circle. So you can't just build anything this time in Explorer. You want to solve that problem and see if you understood those 2 commands. Once you have successfully solved it, you can click Check Code, and it will show you if you have met the conditions. You can also click Submit and Continue, and before it actually lets you through, it'll have a screen pop up, and it will ask, or show you what is happening. And if it gets stuck like this, just refresh the page, which I'm going to do. And it will show you over here, okay, you haven't met the 2 conditions, you shouldn't submit. Close it, and then you want to make sure you keep working until you've done those things. Then, once you have finished it, you're going to move on, and you're going to have a final type of program, which is called a remix. Remixes are where you get to make something else a second time, but this time you get to unleash your creativity. So a remix over here, the goal is to build something using the commands you know and build something cool. Maybe you decide to make a cool pattern, or maybe you decide to do something that you explored earlier when you were working in the example program. So, maybe you do over here circle 10, then forward 10, and then you decide to repeat those two commands, but you're going to increase the circle every time you do that. So circle now 15, and then you're going to do circle 20. Maybe you're like making some sort of pattern over here. And then you're going to make some sort of cool thing and then just explain at the top what your idea was. So it really shows mastery over those commands that you've learned by making your own thing. So remixes are for making your own thing, and that is the P.R.I.M.M framework. We have over here P for predict, to predict what's going to happen, R for run, then see what happens, see if you're right, investigate, was I right, was I wrong? If yes, either way, why was it? Make sure I understand not just each part, but each chunk. So making sure that you see the entire piece of it. Then you're modifying it to play with it to make sure you understand what's happening. And then you get to solve a problem and actually make something so you can apply that new learning. All right, that's P.R.I.M.M, everyone. Video's done. I'll see you in the next one. Hopefully you enjoyed watching. I can't even talk. Peace.